Hi everyone, and welcome to this chapter of Flutter Animations course. In this chapter, we're going to have a look at a simple 3D animation in Flutter. And please keep in mind, the first thing that you need to know is that Flutter, as it stands today, does not support really 3D animations at its core, as you would probably think it does, or unlike what you may think it does. But there is work being done for Flutter, as you all saw the Flutter event in January 2023, that there's work being done to support 3D in Flutter. And at the core of the problem is the rendering engine for Flutter, which is a primarily 2D rendering engine. Even though you can apply 3D transformations to widgets, as we've seen before using the transform widget, these widgets aren't going to be rendered in the 3D space as you think they are being rendered. And I'm going to show you an example of how this actually affects animations. And I think it's important that we have a look at this example together and create it together so you see how basically strange things can look like when you start doing 3D animations in Flutter. So let me bring up a simulator where I have the application running at the moment. Let's just zoom into it a little bit. Like this. Let's see if I can zoom in even more. It's probably not going to allow me to zoom in more. Let's see. Can I stretch it more? Perhaps bring it up. There we go. So as you can see here, we have a cube. And if you have a look at the sides of this cube, one side's brown, green, we have orange, blue, and red. But however, when you start rotating things, you can see like this blue side is kind of like morphing into other sides. And that orange part, which is at the back, is kind of being shown through, even though another side of the cube is being displayed on top of it. So you can, the more you look at it, the more strange it looks, because sides aren't really blocking each other as they should in the 3D space. And this is the problem with the current rendering engine, which is being used in Flutter. There is experimental work, as I said, being done on Flutter to change this engine to a completely new engine that does support 3D rendering. However, that work hasn't really finished yet. So I think what we're going to do in this example is to create this example together. And then you can see how a cube can also be rendered, but also to get an understanding of the limitations that we have to work with at the moment in Flutter. Okay, so basically it's a cube. Our work is to render a cube using normal widgets. Okay, so perhaps using just simple containers, we're going to do this. How can we achieve that? So let's go ahead and create a project first. I'm going to bring up our terminal in here. Okay, and let's just go ahead and say Flutter create example 3, and then we'll say organization for me is SE Pixology, like that. Okay, and let's just say code example 3, and then I don't need this terminal anymore. Let's go here. Get repository was found. Would you like to open the repository? Open it? I don't know. It is open already. So let's just say select device, and I'm gonna say iPhone 14 Plus, and then let's go into main Dart Flutter scaffold application FSA for me, and then let's go to workspace settings JSON, and in here I'm gonna say zoom level 5. All right, so that part is done. I think of our, oops, did I just start select? Oh, I don't even know what I did. I think I started debugging it somehow. Let's go here and say select device. I think 14 Plus was already selected. Let me just see if we can run the application so it's in motion. All right, so while all of this is happening, I'm going to bring up my iPad screen so we can draw a little bit on the screen, and I'm going to show you the premise of this example, how this whole example is going to work. Okay, how can we draw a cube using simple containers? So let me bring up the iPad screen. There we go. Okay, so I'm gonna start drawing a little bit on the screen. So I have to move my chair a little bit. So let's say that we want to draw a cube. What we know already is that, let's say that this is our screen, and then we want to draw a cube. Usually we draw just rectangles. So this one, for instance, okay, is a container. Let's say it's got a width here and a height. Then of course for a cube you have to have different sides, right? So you have the front side, you have the top side, you have the right hand side, and then oops, it looks a little bit strange, but that's, let's say it like that. So this is the front side. This is the top side. You have the back side. So this is T, not J, top side, back side. And then here at the, there we go, like this. Kind of looks strange. But here's the bottom side. All right. And this is the right hand side. So you have all these sides. How can you draw these with simple rectangles? Well, let's say that, let me just create a new note in here like this. Let's say that we take all these sides like this. So we first say here is the front side. Okay. Then we put another rectangle on top of it exactly at the same position, but I render it like this on the screen so you see it's another rectangle. Okay. So we say, let's say that this is the front side. Okay. And then we say this is the, we start with the front and the back side. So let's say this is the back side. How can we make sure that this back side is at the back of the cube? Well, if only we could send it back like this in some sort of an axis. So, and that axis, as you know, we've already talked about the axis in Flutter. We have X, and then we have Y, and then we have Z, which is in the surface of the screen, and it goes in to the screen. That's the Z axis. So if you could take this backside and send it back in the Z axis by some sort of a distance, let's say this distance is 100 points. Okay. So we say, okay, so we draw two rectangles on top of each other. Front stays where it is. And then we have back, which then gets sent in the Z axis by 100 points. Okay. Then we got the front and the back sides. So then we end up with a situation where we have the front, and then we have some sort of a, like this, using some sort of perspective. And this is our back. Oh, maybe I should have actually drawn it separately. Sorry, differently. Here's the front side, and then we have the back side that looks like this. I don't want to draw it into the screen. Okay, so there we go. So we have front and back. Then let's say we want to draw the left-hand side. What do? Well, it is very simple, actually. We draw another rectangle exactly where front is, right here, okay? But we take this axis, which is right there, and we rotate this guy like this, just like a door. Imagine you're pushing in a door. Okay, so you have to now use your imagination in the 3D space. You're pushing in a door by what angle? 90 degrees, which is pi divided by 2. Okay, so you take that and then you rotate this on the which axis? This axis is the y-axis, right? On the y-axis, you rotate that side. You would say, is it clockwise? It is counterclockwise. Okay. Then what do you do if you want to render this right-hand side of the cube, which should be the side that comes here? Well, you take exactly the same container, which is you lay it on top of the front side, and then you rotate it around the y-axis, but from this side. And then you send it to the right. So imagine basically the left-hand side is a door that's got a handle here. And then you push this handle in 90 degrees and you open the door. Okay, so that's the left-hand side. And the right-hand side of the cube is a door that's got a handle on the left-hand side. And then you push this handle in and the door opens like this. Okay, so just use your 3D imagination. So just imagine the left-hand side is just a container that is laying right here that I'm pointing. Okay, just like all the other sides. And you're just rotating it by 90 degrees into the screen. Okay, so that's how we will build a cube. And of course also the bottom side is also very easy. So let's say that you put a rectangle in here and you want to make this rectangle the bottom side. Well, what you have to do is just imagine that it is a very strange door that's got a handle on top, and then you just lay it down on the floor like this. You push it down. Okay, so here is a handle on top. I'm just gonna push this guy down. There's not so many things in real life that look like this, so I can't really make an analogy for how this basically looks in real life, but this angle is also 90 degrees. So you're just pushing this guy around the x-axis, right? This is the x-axis that goes horizontal like this from left to right, and you're pushing it down 90 degrees. And this is clockwise motion. All right, so you're making a clockwise 90 degrees, which is pi divided by 2 angle. All right. And also, for those of you who've jumped into this video without having watched the first and second video, please don't do this. Please go back to the first video because we talked about angles quite extensively in the first video. So I'm not going to explain these all over again. Okay. So that is what we're going to do in this video. So we're going to put, how many is it? 1, 2, 3, 4, 5, 6 basically rectangles on top of each other, or containers. Okay. And then we're going to just rotate these guys and change their axis by doing a translation. So we haven't done that. So you see the right hand side of the cube is going to be doing a rotation. The left hand side is going to do a rotation. The bottom side is going to do a rotation, and the top side as well. They're going to do rotations. However, the back side is going to do something called a translation. Okay, translation is the movement of an object from a place to another place. So if you look here, let's say that we have we want to draw the right hand side of the cube. So you're standing in front of the cube and we want to draw the right hand side. Okay, so this is a container, and then we want to basically take it around the y-axis in here from this point in here. So this is our alignment, and we want to take it 90 degrees to the right so that it stands. If you look from front of it, then it's pretty much just looking like this, okay, with perspective. So now you've moved it to the right 90 degrees like this. Okay, so that's for the right hand side. It's a rotation, okay, around the y-axis. However, for the backside, there's no rotation happening. You literally take a container that is here and you just move it, move in the z-axis back by 100 points or something. Okay, then it moves here. All right, so there's a difference, and that is rotation contra translation. All right, so when it comes to translation, just think of an object moving in some axis, or it could be in one axis, 2 or 3. Okay, just moving it. All right. However, rotation is, well, it's just rotation. For instance, a door, if you open a door, you're not moving the door in an axis, you're actually rotating it around usually the y-axis. All right. However, if you, for instance, take your monitor and you feel like, oh, this monitor that's sitting in front of my face, it is a little bit too close to my face, I want to move it a little bit further away. Then you take like this stem, or you take the stand of the monitor, or even the size of the monitor, and you just push it back. So you're moving back the monitor. That's translation. You're not rotating your monitor, right? If you want to move it farther away from your face, you're not rotating the monitor, you're moving it, and that is translation. That's like the best example I can come up with right now at 5 o'clock in the morning. All right, so now we've talked about the logic that we're gonna apply in this example. So let's just go ahead and kind of create this example and see the shortcomings of displaying 3D objects in Flutter as the rendering engine stands today. So I'm gonna get rid of the widget inspector in here, and let's see what else can we do to clean up the space a little bit. There we go. Okay, so let's start a little bit here, perhaps, with creating some containers. All right, so we could start with all of these containers, to be honest with you, almost at once, because this how do you say, this example won't make sense if we just create the containers and just not rotate them and have them stationary, because all you'll see is just one of the containers, and that's the one in front. Okay, so let's kind of talk also about how we're going to display these containers on top of each other. Well, we need to create 6 containers, right? We have to somehow put them on top of each other and then start rotating them. How do we do that? Well, there's a very, very important component or widget in Flutter, and it is called stack. As its name applies, it just stacks widgets on top of each other. Usually there are different types of stacks, but the main stack widget that we're going to use in here is just called stack, and that stack simply stacks components on top of each other. Okay, so that's the main component that we're going to use for almost all our animations in this course. I think stack is going to be pretty much in every animation that we're going to develop. All right, so we're going to create a stack, and on top of that stack, we're going to place 6 containers. So let's go here in the scaffold. First of all, we're going to get rid of the app bar, and then let's create a body, and we say body, and then let's say the body is, let's start with the stack. And then we say children, empty. And then usually I start from the deepest component and then I go up because it's so much easier to wrap components within each other. So let's say the stack should be wrapped. I think let's just put this stack within a column. So let's say we wrap it within a column. And then we want to, let's say column we have there. That's good. Let's put on top of this one a sized box with a height of 100. Okay, and again, this is not a Flutter course really, so I'm not going to explain all of these very small details. This is an animations course. You should already know how to use Flutter, and this really is there just so we can get this little top spacing in here. Okay, just a size box of 100, and let's just say its width is double infinity, so we take the entire space, and there is a comma missing somewhere. Okay, and that's our size box. And let's say the column's cross-axis alignment is center because we want the components to be in the center. Okay, I think the structure is ready. Let's put this column also within a safe area. So let's say safe area. Good, we have that in place. And then in the stack, we can actually start testing our setup. And I can see our application is running as well. I think it's on an iPhone 14 Plus. So this is our app on the left-hand side, and on the right-hand side is the one that we are going to develop. So I think now we got the gist with what we're going to develop. So I'm going to get rid of it like this. So we only focus on our application. So let's go in our stack and just create a container. We say container, colors is red. And then let's just say, oh, this can't be a constant anymore. And let's say width 100 and height is also 100, something like this. Okay. And let's see how it looks like. There we go. So we have the basic setup ready at the moment. So what we need to do is to create 6 rectangles in here. Okay. But perhaps before we do that, let's create our animation controllers and start animating this thing already. All right. And I actually don't know the width and height of the containers. Let's just go with 100, but let's kind of put this in a constant. So let's say width and height is 100 like this, because otherwise we have to repeat this 12 times because we're going to have 6 containers, right? Let's see what happened here. Width and height, too many positional arguments. The argument int can be assigned. Okay, so this should be a double like this. And then we have heights as well in here. There we go. Otherwise, because we have 6 containers and each of which is going to have width and height, so there's going to be 12 repetitions of the number 100. So in here also height, let's just say width and height like this. And the result is pretty much the same as it was before. So we don't see any difference on the screen, okay? Good, let's go ahead and create our animation controllers. Animation controllers need a stateful widget because we need to dispose of them unless you're using Flutter hooks, and we're not using Flutter hooks at this moment. So let's say convert to stateful widget. Then we're going to go in here and create 3 animation controllers. And the reason for that is that, as you can see in here, we are rotating this entire box in three-dimensional space around the X, Y, and Z axis. All right. The animation, to be honest with you, is not that important. It's just so that we can see all sides of the cube. All right. So let's go ahead and create 3 animation controllers in here. And I'm just going to copy paste those because it's kind of difficult to write all of these, or just takes time. All right. And let's just go ahead. And also, before we go ahead and do something else, I just want to show you the reason that this animation looks smooth is that we're going to have different duration for the X, Y, and the Z axis animations. All right. If we didn't have different durations, this animation would look really, really linear and it would look very boring. Okay. I mean, it is boring, but it would look even more boring if you created a linear animation for all 3 axes. So let's go ahead and also assign an animation in here, because we want to rotate our cube in three-dimensional space 360 degrees around all the axes. Okay, and 360 degrees is pi multiplied by 2. So we have a simple animation. Let's say late animation of double. Okay, and we call it animation, just simply like that. And let's go in its state. And this part is very, very simple. We've already talked about this before. We're gonna have to create the X controller. We say this is an animation controller. Let's say it takes 20 seconds. And VSync, we're gonna have 3 animation controllers in here, so we can't be a single ticker. So we can't say single ticker provider state mixin, because we're going to have multiple animations, as you'll see in here. If I go ahead and create a Y controller, and I say Y controller is like that, somewhere we should, oh, right, we don't get a compile time error, but if you run your application, you will get a runtime error, an exception, telling you that you can't have multiple animation controllers bound to a state object or an object that is conforming only to a single ticker provider state mix. And a single part of it simply states that you have a single animation controller. And here we have 3. So just remove that single part. Okay, there is another mixin with this name. Okay, so for the Y controller, we're going to say it takes 30 seconds. And for the Z controller, or Z controller, as some people call it, we're going to say it takes 40 seconds. All right, our animation is going to be a full 360 degrees animation. And we're going to just say it's a tween. So animation is, we say tween, a double, and we say it's a value. So let's say it goes from, I'm going to remove all of these like this, and this. And also, I think our animation, we need to change it from animation to tween. Okay, and I'll explain soon why we're doing it. You see, an animation object, oops, pi divided by 2, and we don't have pi, so let's just import math. And I like to go and say show pi only, because that's the only thing that we need in here. Okay, there we go. Okay, so all right, I was just going to explain the difference again between animation and tween. A tween is an object that says between. It says a value that's between begin and end. That's it. An animation, however, is probably, it can be a tween. It doesn't necessarily have to be a tween, but it's some sort of an animation that is bound to a controller. Okay, and this guy's not at the moment bound to any controller. When you bind it to a controller, you use drive. So you say you drive, oops, tween, and animate, sorry, you animate a controller like this. So X controller, I think we call it X controller. So if I say final blah, and then you can see all of a sudden blah is an animation. All right, so it's when you animate a tween, for instance, you can animate multiple things, but a tween can also be animated using an animation controller, and then you get an animation object back. But if you don't drive a controller with your animation, then you actually get the actual object back. Okay, so that's the difference. So this guy at the moment isn't doing any animation, but I'll show you later how we can actually bind it to some sort of a controller. Okay, good. So now we have our animation, we have our objects in here, and we need to ensure that we're disposing of our controllers as well. So let's say dispose. I'm not going to explain this part so much. We've already done this many times before. Okay, and there we go. And I'm just going to restart our application. Let's have a look at the debug console. No errors. Looks pretty good. Okay. So now that we have these guys, what are we going to do? We're going to go ahead in the build function and actually start them. So let's say X controller, and I'm going to say reset it when the build function is called. And then I'm just going to say repeat it. And going to do the same thing with the Y controller. Oops. Let's see if GitHub Copilot can complete this, and the Z controller. Okay. I really, really like GitHub Copilot. And that's simply because it helps me as an instructor to write code so much faster. But also, I understand. I mean, this is a little bit of tangent in this course. Doesn't necessarily have to have anything to do with this course, but I feel like it in order to be able to fully utilize like any AI when you're programming, is like you need to actually know what you're writing. If you don't know what you're writing, you're just going to accept all the suggestions from GitHub Copilot, and all of a sudden you're going to end up in like a tangle of horrible code that you have no idea how to fix. Okay, but since this code, I've already written this, GitHub Copilot is actually suggesting the same code to me, which is really good. Okay, good. We're done with that. Now, what we're going to do is this stack guy, is we're basically going to animate this whole thing. Okay, so let's put this guy in some sort of an animated builder. So I'm going to say this guy is wrap it with widget animated builder. However, this animated builder is the only animated builder that we're going to have in this example. In the previous examples, we've used multiple animated builders and we've just bound one controller to each animated builder. And simply is because if you look at the animation of this guy, it says, give me a listenable. You'd be like, okay, but listenable is just one object. It's probably like X controller or Y controller. How can we give all three to this guy? And that's a good question. In the previous two examples, as I mentioned in those examples, we could optimize the examples so that they don't need multiple animated builders. And in this example, I'm going to show you how to merge these controllers into one listenable. All right. So the trick to that is to say listenable.merge, and then you give it an array of listenables. There we go. So now we have three animation controllers, each of which is fed into this array, which is inside the listenable, and then you just get one listenable back. All right, and I'm going to show you actually how to extract these values from the animated builder. Okay, now we have the animations fed into animated builder, but we're not actually animating anything. All right, so let's go ahead and first of all add the builder parameter here. So we say builder, and this is the context, and we get the child back. All right, so in here, let's take this stack out and remove this, and then just return it in here. And also, at the moment we have this stack guy in here. Let's go ahead and apply some sort of a transform to it, because we have our animation controllers in here, but we're not applying the animations to anything. So after we put all the sides of our cube inside the stack, we want to rotate the entire stack in all three axes. Okay, so the x-axis, y, and the z-axis. So let's put this entire stack inside a transform. So I'm going to say it's inside a transform. Okay, and this transform says, okay, remember, the alignment is very important. Where are we gonna do the animation from? Where are we pinching our fingers and saying this is the pivot point? Well, we want to rotate it around its center. Okay, so I'll explain alignment a lot in the previous example, so please watch the previous examples if you haven't watched them already. So let's go into alignment, and let's say the alignment is center. All right, and then let's say, well, what is the actual transformation that we're going to do in here? Okay, this part's very important. Let's start with matrix 4 identity. So we say zero out everything. The transformation at the moment is completely zeroed out. Okay, again, this is something I've already explained before. So we're getting an error in here. It says Z controller has not been initialized. Let's have a look and see if that is true. Z controller, I can see Y controller is being initialized twice. So let's go ahead and say Z controller is initialized now. Okay, so everything's zeroed out. You can see nothing is happening on the screen, but we want to rotate this guy around the X, Y, and Z axis. And we have our controllers in here, but we only have one animation. So how do we do that? How can we bind an animation to multiple controllers and say, okay, the rotation of 360 degrees around the X axis should take 20 seconds, and around the Y axis 30, around the Z axis 40. How do we bind this to multiple controllers? Well, there is a function on tween, or let's actually go ahead in here. Yeah, it's on tween. Let's just say it's on tween at the moment, which is called evaluate. And this evaluate, let me show you how it works. You can bind it basically, you can bind a single tween to multiple animation controllers. Okay, so I'm going to say here, rotate Y, and let's just say by 0 degrees. Rotate X 0 degrees for now, and then we also say rotate Z by 0 degrees like this, and then we have them on separate lines. So let's then say rotate, let me put X, Y, Z for those of us who are OCD, including me. So let's say around the X axis we want the animation, all right, but we want to bind it to the X controller. So we say evaluate, and then we say X controller. So it's a 360 degree animation that takes as long as the X controller takes. Then we take the exact same animation. Okay, be careful with copy pasting in here. Make sure that this is the Y controller, and then the same animation on the Z controller. So this is a good trick for you to learn, so that it's kind of like an optimization trick that you can ensure you have one animation which is bound to different controllers. Okay, so there we go. That's our transform. So let me bring our container in here, and I'm just gonna resize this a little bit. Let's see if we can resize it. There we go. I have no idea where this is now. Okay. And I'm gonna just restart this whole application. There we go. Now you can see we have our little rectangle, which is being rotated in all three dimensions, X, Y, and Z. Isn't it cool? So basically you have a container that's just rotating. All right, so that's the front side. But I think we need to decorate that front side a little bit more, to be honest with you. So let's see how we can make the front side a little bit nicer. Let's say that the front side, let's go in here and find it actually. There we go. Where is it? It is here. At the moment, it's just a container with the color of red, but we're gonna make it green. So it is just like in the example. All right. Then what we're gonna do is to have a look at the Z transformation. And that is the part that trips up a lot of people. So we need to talk about it a little bit. So let's restart our app right now. And let's see that it has turned into a green container. And as you know, as I explained on the iPad screen, this front side of the container, of the cube, is not really going to have any kind of transformation of its own, because it's just going to be placed on the stack and everything else around it is just going to rotate around different axes. So it's kind of like opening a box. The front side is kind of like going to stay where it is. And let's just say you have a flattened out box and then you're just going to open different sides and the front is just going to stay where it is. Okay, so you really need to use your 3D imagination in here. Okay, so let's say that the front side has no type of effect, and let's just say we're going to build the back side. All right, so let's create a container in here which is for the back side. Let's put a comment and say front, and let's say then we have the back. Let's copy this container like we have in here and say here's the back. And for this container, let's change the color to purple. All right, I'm gonna move this color down. So I think the colors should be after width and height, which I think the width and height is a little bit more important. You could argue differently. You could say that the color is more important. So let's just move those up. For me, it doesn't make any difference, but I think we should at least be consistent. Let's just put the color on top. Okay. So the container, which is at the back, should actually be sent back in the Z axis. So it has to have its own transformation. All right. So let's say that we wrap it within a widget. We call it, it is called transform. And let's say the alignment is in the center. Okay. We want to do the apply the transformation from the center. And then we say that we want to take a transform, which is identity, and then we want to translate this guy. We don't want to rotate it. We say translate. Remember moving of the monitor that I mentioned? And then we want to move it back in the Z axis. So we say move it back by the width and height. All right. So if we run our animation now, oops, unimplemented error, something happening here. A render. Okay. Let's see what happened. Vector 3. Oh, right, because the translation at the moment, we're doing width and height, but the values are only between 0 and 1, but we're applying a value of -100 in here. So let's say that we want to create a vector 3 in here, okay? And then we have to actually import some sort of a package for this guy. So perhaps we could do that now. It's called vector math. All right, so let's go in here and say Flutter pop add vector math like this. And then we go in here and import it. So we say import vector math like this. I think vector math 64, and we say show vector 3. All right. Then let's go back to our code in here and vector 3. Let's put it in a separate line, and we say 0, 0, and minus width and height like this. All right. So let's restart our application and see how it looks like. Now you can see that the purple part is actually, which is the back part of our animation, you can see it's got its distance now from the top side, right? So we got that working now. So we sent this guy back into the Z axis. All right. But as you can see already, it looks a little bit strange when they rotate on top of each other. And that's simply because Flutter isn't, the current engine we're using is not a full, you see, it's kind of like appearing on top of it, even though it looked like it was behind it. So this is the part that we have to live with, but at least we're getting the animation right. Okay, so that's good. let's leave it like that. So we got the back part working. So let's continue with the sides now. And the sides are going to happen between the front and the back. All right. So let's go in here. I mean, the thing also you need to realize is that the reason that this is happening is that we're rendering the back transform, this widget, after the front. Even though it's sent back into the z-axis, it's still, I mean, it is, maybe actually we could play with this a little bit. So let's say this is like plus value. But you can still see the purple one is rendered in front, but then if you send it back, I mean, they both work the same. But if we move this guy up, it will be a different result. So let's say stack here. So we do this. Now you see it is rendered behind it. All right. And simply it's just because stack renders its components kind of like JavaScript renders or reads code. Okay, it's just like from top to bottom. So first it renders this, and then it renders this on top of it. All right, so that's it. So you could leave it like that. You could say this is back and that's front. So let's move this comment as well up here. There we go. Good, we got that part working. Let's work on the sides now that we got the back and front. So we could start with the left-hand side. So right after this, let's say left side. And for the left-hand side, we have a red container. So I'm gonna we could perhaps take the back here, copy it, and paste it in here for the left-hand side. And we just start with identity at the moment, and we say the color for this guy is red. All right. However, remember the red hand side, sorry, did I say the red hand side? Yeah, the left hand side has to rotate around the y-axis. All right, and let me bring up the iPad screen. I think this is a little bit important to explain on the screen. So let's create a new note in here. So what we have is this kind of a container in here. We place it for the left hand side. LHS, okay, left hand side, and we want to rotate it around this y-axis in here like this, kind of like a door with a handle here. So the handle, if the handle of the door is on the right hand side and you open the door going in, then the door goes like this, and it is pretty much pivoting around this axis, right? So it's pivoting at this point, kind of, it's pivoting basically like this. Okay, so it's pivoting around all these points. How can we specify that? Well, that is using transform and its alignment. So we're going to say alignment is center left, okay? And then we're going to pivot it 90 degrees or pi divided by 2 onto the y-axis, okay? So the same thing we could say, maybe I should explain it right now. So if we have the right-hand side of the cube, then we're going to pivot it around the y-axis again, right? Both are y-axis. This one and this one are both y-axis. We're going to pivot them 90 degrees like this, or pi divided by 2 again. But one is going to be a plus, the other one is going to be a minus, right? Because one is like pivoting like this, which is a counterclockwise, and this one is clockwise, all right? So, but the angle is the same, is pi divided by 2. And it's the right hand side, it's kind of like a door that's got its handle on the left, but it's pivoting around all these points. Okay, so the alignment is going to be center right, and the alignment for this one is going to be center left. And again, we've talked about alignments a lot before, so I'm not going to explain them again. Okay, so let's start building. Let's go back to the code. I'm going to have to move my chair a little bit. Okay, so we're working with the left hand side. So let's move this guy and say we want to rotate it around the y-axis by a positive angle of pi divided by 2. All right, so let's say rotate y, and we say pi divided by 2, like this. Or you could just do it like this, doesn't matter really. Actually, it does, no, it doesn't matter. I think the division will be double anyways. Okay, and we also need to make sure that the alignment isn't center. It should be center left, like this. All right, so let me just restart our application and have a look at the simulator. There we go. Now we got that working. Let's have a look. I'm gonna restart the app, 1, 2, 3. There we go. You can see the red hand side. Sorry, the red container is on the left hand side. All right. So if I restart it again, you can see it starts from the left. You see? Okay, so let's now work on the right hand side. So I'm gonna take this transform, left hand side like this, and we can work on the right hand side. I'm just gonna copy paste that and place it right here. The right hand side is gonna be blue like this, and also the rotation is gonna be exactly the same, but it's gonna be on a minus angle. Okay, and then also in here, the pivot point, remember, is on center right. Okay, I just drew that on the iPad screen for you. There we go. So now we got the blue, which is on the right hand side. Now the only sides that we're missing are the top and bottom. All right, so right after this front side, perhaps we could render the top and bottom. So what I'm going to do is I'm just going to take the left hand side. Right after front, we're just going to say top side. All right, so the pivot point for this guy, let me bring up the iPad screen here, create a new document. So if we want to take this container in here and kind of like move it to the upside of the cube, it's as if you have a handle down here and you just push this guy up by 90 degrees around this axis, which is the x-axis, and our pivot points are here, which is kind of, you could say, top center. Okay, top center. Okay, and we need to move it up basically around the x-axis. So let's have a look at how we can achieve that in the code. Oops, did I just put a breakpoint? So let's say top side, and also say the top side has a pivot point of top center like this, and we're going to rotate it around the x-axis. All right, and we're going to leave that angle like that. All right, and the color is going to be orange. So let's have a look at the results. Oops, here, there we go. That's the top. I'm going to restart the animation. Let's see. Like this. There we go. All right, and also then we're going to have the bottom side. So I'm going to copy this, and let's just go ahead and copy and then go in here and say bottom side. I'm always really wary, not so big fan of copy pasting, to be honest with you. And let's say bottom center, which is the pivot point for the bottom side, just the opposite of the top side's top center pivot point. And the rotation is going to be exact opposite of the top side. All right, there we go. So, and the color, I think, was brown. All right, so there we go. Now we have all the sides, and I'm just going to restart the animation, and then you can have a look. The bottom is here, which is the brown one, and then the rest of the parts are also there. But this whole animation, I mean, we're done pretty much with this example, but this whole animation looks really strange, and not the animation itself, but the result, how it looks on the screen. And that is simply because the current rendering engine in Flutter, and especially how widgets are rendered on the screen, are kind of rendered in 2D space, kind of. It's not going to be able to draw these sides for you correctly and understand that, hey, oh, this brown thing, like, it is on the right hand side, so when it rotates, I should hide it behind the ones that are displayed on top of it. It just doesn't understand that. Okay, so that's why this animation at the end, when you look at it, things just morph into each other, and one side that should not be displayed gets displayed in certain angles, etc. Okay, but I still think it's an important exercise, just so you exercise like rotating stuff, pivoting stuff with transform. Okay, so hopefully you enjoyed this example. In the examples to come, now that we've talked about the like the shortcomings of the current engine in Flutter, we're going to work with some applicable examples of how animations can be used within Flutter, and we're also going to work around some of these limitations in the coming examples. Hopefully you enjoyed this example, and see you in the next one.